All right, let's do some more word problems. Here I am. How's it going? Today we're going to do word problems not using perimeter this time. We're going to do just a regular everyday kind of situation that uses systems to find the solution. So I'm going to show you some different methods, and then I'll probably do another video on how to use your calculator to solve our systems. So here's how we need to go. So let's look at your notes. Here's what the notes problem or the notes worksheet looks like. We're going to deal with cost word problems. All right, well, cost problems have to deal with some real life stuff. All right, so if you take a look at number one, it says the cost of 1 onion X and 4 tomatoes T is $5. 5 onions and 10 tomatoes cost $15. What's the system of equations that can be used to cost of each onion, to find the cost of each onion and each tomato? Well, this is something that we run into every day you go to the grocery store. So, first off, we need to translate the equations. That means we need to go through your equation and pick out words that mean mathematics. So, I see the first sentence. It says the cost of 1 onion X and 4 tomatoes is $5. The word "and" tells me addition. The word is an equals word. All right, so this first sentence is actually an equation. It even gives us a variable, right, and it gives us some numbers. So obviously 1 onion would be 1x. The word "and" tells me a plus sign. Then I see the word 4 tomatoes. So 4, we're going to use T for tomatoes. And then the "is" word is the equal symbol, and that's going to be $5. And that's an equation, ladies and gentlemen. All right? So that's the first equation. The very next sentence gives us our second equation. This one says 5 onions and, again, that means plus, 10 tomatoes cost $15. All right, well, 5 onions, we're using X for onions because that's what it's there, plus 10 tomatoes, so 10T, equals $15 this time. All right. Now here's the important thing. This is going to save you some time. The question says, what system can be used to find the cost? Did it actually ask me to find the cost of each onion and each tomato? No. I just want the system. So it does not require me to solve, and I don't need to know the solution. So setting it up is as much as you need to do. All right. Now you will have some problems that ask you to solve. Example number 2 is a prime example for that one. So let's look at that. I'm going to move this down a little bit. Number 2 says the cost of 7 hot dogs and 3 Cokes is $20. 1 hot dog and 1 Coke is $4. What's the cost of each hot dog and each Coke? This one actually wants us to figure it out. Okay, so let's do that. We're going to do the same thing. I have a similar type of problem. So 7 hot dogs, and it says to use H for hot dogs, so H is going to go right there. 3 Cokes, it says to use Cokes, or C for Cokes. There's that "and" word again. That "and" word is going to be my plus sign. Okay, and then we have our equals word. That needs to be there. So let's write this equation. We have 7H plus 3C equals 20. That's 7 hot dogs plus 3 Cokes equals $20. All right, the second equation says 1 hot dog, and there's that "and" word again, 1 Coke cost $4. Now the word "cost" in this situation is very similar to the word "is." I didn't talk about it up here, but it is the same thing. That's our equals word. All right, so 1H plus 1C is equal to 4. All right, now let's talk about this system real quick. So far in class, we have talked about solving systems by graphing. All right, we have put 2 equations in y equals mx plus b. shown them on a graph, and where the two lines cross, that point of intersection has been my solution. All right? Well, I obviously cannot do that with hot dogs and Cokes because they're not X and Y. Now you might be saying, hey coach, we could change it to X and Y and we could make it look like Y equals MX plus B and put it on a graph, which we could. However, I don't have a graph anywhere on my problem. So I want to remind you and show you a new method of solving systems. I briefly touched on this using your calculator a couple lessons ago, solving systems by graphing using your calculator. But you can do that using just a regular old situation like hot dogs and Cokes. We can go straight to our calculator and we can solve our system. All right, so let's get out our calculator because this is where we're going to solve this system. So your calculator looks a little something like this. If it's already got something in there, don't worry about it. We can always clear it off. Remember, clear off the scratch pad by clicking on Documents and then Clear Scratch Pad, or you can say Doc B, whichever. And we are going to put this system into our calculator using matrices. Now, if you have not already heard me talk about this in class, then stop watching the video right now. All right, I will talk about it in class, okay, and you'll be able to get it more if I've talked about it in class. All right, so the whole matrices thing. Use matrices to solve systems by taking the coefficients, which are the 7, the 3, the 1, and the 1, and putting it into your calculator. So remember, your matrices button or matrix button in your calculator is right there above the multiply sign, and it's the one that has the brackets with the 4 spots in there. That's what we're going to use first because our coefficients make up 2 rows and 2 columns. So we want to click on that one, and we're just going to put the numbers in there. So that means we're going to put 7 in there, we're going to put 3 in there, that's our first row. And then we're going to put 1 in there, and then the other 1 in there. And then get out of that first matrix, and we're going to give it this exponent. So hit the rooftop button, that puts us up in the exponent blank. We're going to give it a -1 exponent. That's the inverse exponent. All right, we're using that property of matrices to solve our system. Now we need a matrix for the answers over here, the 20 and the 4. So go back to this button. We want this one. And let's put 20 on the top, 4 on the bottom, and then hit enter. When you hit enter, this matrix over there that your calculator gives you is your answer choice. So get over on your nodes, and the matrix right here, this is going to be the first variable in your system. This is going to be the second variable in your system. So our first variable is H. So this is $2 for hot dogs. The second variable in your system is C. This is $2 for Cokes. So $2 hot dog and a $2 Coke. And that's how you do some more word problems.